Hello everyone. In this video we're going to take everything that we've learned about nomenclature and we're going to bring the whole rule system together in this 3x3 grid. So there are a lot of nomenclature rules and we have to be very careful to follow the correct rule when it's needed, and this 3x3 grid will help us remember which rule to use for which category of species. So what we're going to do first is label the columns. A, acids. B, ionic compounds. C, covalent. And then we have rule 1, 2, and 3. For acids, the 3-rule set is if it is an IDE anion, the acid is named with a hydro prefix. The root word for the acid, an IC ending, and then the word acid. Hydro something ic, acid. If the acid is an ITE, anion, then the acid is named with no hydro prefix, just the root word for the acid and an OUS ending. And if the acid is based on an ATE ending for the anion, then there is no hydro prefix, just an IC ending on the anion's root word and the word acid. And those are the 3 rules for acids. And remember, for acids, you're only going to pick one of them. You're not going to apply all 3 rules, you're just going to apply one of those rules, and it's going to be based on the last 3 letters of the anion's name. Second category, B, ionic compounds. The first rule is that we name the cation. And we may need a Roman numeral to name the cation. If it's a variably charged metal, we will need to use a Roman numeral. So Roman numeral, and I'll put a question mark here because it may be necessary to name the cation, the metal cation. The second rule for ionic compounds is that we name the anion. And remember that if it's a monoatomic anion, it has an IDE ending, and if it's a polyatomic anion, then we just have to name that anion. And the third rule for ionic compounds is name the hydrate. If it exists, so I'll put a question mark there. Name the hydrate. And if it is a hydrate, then we always use the Greek prefix. So I'll put a little exclamation point there to say, if it's a hydrate, then we always use the Greek prefix. Even for only one water molecule, we would use the mono prefix in that case. And those are the 3 rules for ionic compounds. For the next category of compounds, covalent compounds, the first rule is that we name the first element. The second rule is that we name the second element. And the second element always gets an IDE ending. So I'll put a little exclamation point there so that it conveys that we definitely always use the IDE ending on that second element. And then finally, the third rule for covalent compounds is we use Greek prefixes. For the numbers of each, with the exception that the first element does not get the mono prefix. So the first element never gets mono. So that's the whole system right there. 3 categories, 3 rules for each category. So the most important thing that you can do when you're facing a nomenclature question is to ask yourself first, A, is this an acid? B, is this an ionic compound? Or C, is this covalent? And once you've asked yourself that important question, then you can apply the 3 rules for that species. So again, the first and most important question you ask is A, is it an acid? B, is it ionic? Or C, is it covalent? And once you've answered that, then the next important thing that you do is you begin to apply the 3 rules for that category. So now on this page I have several practice problems for you. There are 8 practice problems where I have given you the formulas and I'm asking for the name. And 6 more where I'm giving you the name and I'm asking for the formula. So this practice problem set is different from the sets that I've given you in the past, because the ones in the past have told you which category the chemical species belongs to. So you already knew that it was an acid that we were dealing with, for example. But now they're all mixed in together. So there may be acids, ionic compounds, and covalent compounds. So you have to ask yourself that question first. Which category does it belong to? And then once you have identified it, then you can apply the appropriate rule set. So go ahead and give that a shot. See if you can work through all 8, and 6 is 14 of these problems. Pause the video to do that. And when you're done, resume the video, and then I will work through these, and you can check your answers. But for now, you can treat this as if it were a practice quiz. You'll have these rules up here that you can refer to. If you need to refer to your notes for your polyatomic ions, at this stage you can do that. But go ahead and pause the video now and work on those 14 and resume the video when you're finished. All right, coming back to these practice problems, I'm going to run through them fairly quickly using our rules and what we know about nomenclature. A, is this an acid? No, there's no hydrogen in the first position. It's not aqueous. B, is this ionic? Yes, magnesium is a metal, so this is an ionic compound. So I use my 3 ionic naming rules. I name the cation with a Roman numeral if I need it. I name the anion, and then I name the hydrate if it exists. Well, we can see right away that there's no hydrate there. So I'm just going to name the cation and the anion. The cation is a magnesium. It does not use a Roman numeral because magnesium is fixed charge. Each magnesium is a +2 charge, so I have 3 of those +2s for a total of 6 positives coming from the magnesium, which means these 2 nitrogens must be giving me 6 negatives, which means that anion is a nitride. So there I have magnesium nitride. A, is it an acid? No. B, is it ionic? Yes, there's calcium and it is a metal, and this is a dead giveaway. This is a hydrate. So those are ionic compounds. So I name the cation, that's calcium. Name the anion, SO4 with a 2- charge is sulfate. And is it a hydrate? Yes, it is, and it has 2 waters, so it's a dihydrate. And I've named it. A, is it an acid? No. B, is it ionic? Yes, manganese is a metal. So it's ionic, so I name the cation, that's a manganese. But manganese is variable, so I have to have a Roman numeral to designate its charge. What is the charge on that manganese? Well, it's paired up with 3 hydroxides. Each hydroxide is an OH minus 1. I've got 3 of them, so I've got 3 negatives from the anions. That manganese must be offsetting all 3 negatives, and so the manganese must have a charge of a positive 3. So that cation is a manganese 3 cation. The anion is hydroxide. A, is this an acid? No. B, is this ionic? No, I don't see metal or ammonium in the first position. So if it's not A, an acid, or B, ionic, it must be C, covalent. And indeed, I do have 2 nonmetals here. So this is a covalent compound. So I use the covalent naming. I name the first element, sulfur. I name the second element with an IDE ending, oxide. And I use Greek prefixes with the exception that the first one never takes mono. So the first one, the sulfur, there is only one of them, but the first one never gets the mono prefix, so I'm not going to write mono there. There are 2 of those oxygens, so that's going to be a dioxide. Sulfur dioxide. A, is this an acid? No. B, is it ionic? There's a metal, so it's ionic. Name the cation, potassium. Name the anion. MnO4 with a minus charge is the permanganate ion. It is not a hydrate, so I'm done. Potassium permanganate. A, is this an acid? Yes, it is. Hydrogen in the first position, aqueous state indicator. So I have to determine the name of the anion. The anion is a PO4 with a 3 minus charge on it. How do I know it has a 3 minus charge? Because it's being offset by 3 positive hydrogens. So what is PO4 with a 3 minus charge on it? That's the phosphate. So this is based on phosphate. So the acid must follow rule 3, root word IC. Root word for a phosphorus-containing anion is phosphor. IC ending, acid. Phosphoric acid. A, is this an acid? Yes, this is an acid. What is the anion name? Well, it's just an F with a minus charge on it. The name of an F with a minus charge on it is fluoride, IDE ending. So it follows Rule 1 convention. Hydro prefix, root word ic. Hydro prefix, the root word for that fluoride is fluor. Ic ending, acid. Hydrofluoric acid. This is an odd compound. Xenon is a noble gas. Why in the world is it in a compound when we know that noble gases don't react? Well, in fact, in some very highly controlled conditions in the lab, we can get some of the larger noble gases to react with fluorine. So we do get some compounds with noble gases, but they don't occur in nature. A, is this an acid? No. B, is it ionic? No. C, is it covalent? Yes. And we have 2 nonmetals here. So for covalent naming, we have name the first element, xenon. Name the second element with an IDE ending. Remember, fluorine has the flu, FLU, to start, right? And then rule 3, Greek prefixes to show the numbers. There's only one of the xenon, but the first one never gets mono. 4 is tetra. So xenon tetrafluoride. Xenon tetrafluoride. Moving on. Hypobromous. This is not a hydro prefix, so it's not from rule 1, acid. This is an acid. Hypobromous, OUS ending, must have come from an ITE anion. So this came from a hypobromite. So let me just write that out. Came from that anion. So how do I turn that anion into an acid? I add enough hydrogens to offset the charge. So it only needs one hydrogen. And then I always give acids. In this class, I always give acids aqueous state indicators. Next one, is this A an acid? No, it doesn't say that it's an acid. Is this B ionic? Yes, there's a metal cation right there. So it's an ionic compound. So this ionic compound must have been generated by naming the cation first. So a nickel 2 cation. So a nickel. And it has a 2+ charge on it. And a nitrate is the anion. So how many nitrates do I have to balance that nickel 2? I have to have 2 of them to charge balance. And that's how we show that we have 2 of them. Nonahydrate. So I do have a hydrate here, 9 waters. So dot 9H2O. Nickel 2 nitrate, nonahydrate. A, is this an acid? No. B, is it ionic? No metal here or ammonium, so it's not ionic. C, is it covalent? Must be covalent if it's not an acid or an ionic compound. So if it's covalent, it was named with the covalent naming rules. I named the first one nitrogen. I named the second one an iodide with an IDE ending. So there's my iodine. And I had Greek prefixes to denote how many of each of these I have. There's only one nitrogen, but I have 3 iodides. There's the formula for nitrogen triiodide. A, is this an acid? No, it doesn't have the word acid in its name. Yes, there's a metal. Vanadium is a metal. So this is an ionic compound. So the name must have been generated by naming the cation first. So I've got a vanadium 4. And then I've got a carbonate. So we can see that we need 2 of these carbonates to charge balance with that vanadium 4. And there we have vanadium 4 carbonate. And they're charged balanced. Zinc azide. Is this an acid? No. Is it ionic? Yes, zinc is a metal. So if this is ionic, then I must have generated the name by first naming the cation, zinc. There's a zinc ion, it's fixed charge. It's fixed charge at 2+. Azide, there's the anion. Polyatomic anion with 3 nitrogens and a single negative charge. So I can see that I needed 2 of these azides to charge balance with the zinc. And we use parentheses to show that we have more than one of the same polyatomic anion. Zinc azide. And the last one, hydrosulfuric acid. So we have a hydro prefix here. That indicates that the anion had an IDE ending. So this sulfur used to be a sulfide, which was that formula, S with a 2- charge. So that's a sulfide, and so the acid based on that IDE ending has the hydro prefix and the ic ending. So if that's the anion upon which the acid is based, I needed 2 hydrogens to charge balance that. And of course, aqueous state indicator always for acids in this class. And there we go.